Good morning students, we are going to continue with the same chapter in chemistry, that is chapter 4, but our topic today will be covalent bond. In the last video, if you remember, we discussed about ionic bond, and ionic bond, as you know, is the bond that is formed between metal and non-metal by the transfer of electrons from one atom to the other. But unlike the ionic bond, this covalent bond is formed between two or more non-metals. One important thing to be noticed here is that it will always be formed between two non-metals, and it will be formed by mutual sharing of one or more pair of electrons. So there will be no transfer of electrons from one atom to the other. Instead, there will be mutual sharing of electrons taking place between the two combining atoms, that is between the two non-metals. We have some examples of the compound which is having a covalent bond between the two. You can see hydrogen chloride. If I write hydrogen and chlorine, these two are non-metals, and the bond between these two non-metals will be covalent bond. And this compound is called covalent compound. We have another example of NH3. Here nitrogen is one non-metal surrounded by three hydrogen atoms. And you can see the bond between nitrogen and hydrogen once again is a covalent bond, because here also all these atoms are non-metals only. Coming to oxygen, there are two oxygen atoms, and it is found that there will be two double bonds. That is, there will be two covalent bonds here, and that we can see when we discuss about electron dot structure, that how these two bonds have come in oxygen molecule. Next we have water. It also has covalent bond. But draw the structure, this is how it will be. This is oxygen with two hydrogen atoms bonded with two covalent bonds. So as I said, these are the bonds that will be formed only between the two non-metals, and these all compounds that contains covalent bond in it will be covalent compound. Let us now see how this covalent compound or covalent bond is formed between the two combining atoms. So we are going to see with the help of electron dot structure. So before coming to the electron dot structure, we are going to see the types of covalent bond. So there are three different types of covalent bond. Depending upon the number of bonds between the two combining atoms, we have single covalent bond, double covalent bond, and triple covalent bond. Let us see examples of each of these types of bond, starting with single covalent bond. We have the example HCl, because when you draw a structure, you will find there is one, that is only single covalent bond between hydrogen and chlorine. Another example is H2, where you can draw, you can also see there are two hydrogen atoms with only one bond between the two atoms. This is single covalent bond. Next, coming to double covalent bond. Double covalent bond, we have example, very common example is O2. Just now I showed you there will be two bonds between two oxygen atoms. This is how the bonds is. Another example of the molecule containing double bonds will be C2H4. That is ethene molecule, and you find the double bond between two carbon atoms surrounded by 4 hydrogen atoms this way. You can see there is double bond between 2 carbon atoms. We have this as example of double covalent bond. Let us now see about triple covalent bond. We have example like N2, that is nitrogen molecule. So there will be 3 bonds between 2 nitrogen atoms. Another example can be C2H2, which is called ethyl or acetylene, where in this case you will find the triple bond between 2 carbon atoms. And there will be 2 hydrogen atoms bonded with carbon atoms with a single bond. So we have these 3 types of bonds. One is single bond or single covalent bond, then we have double covalent bond, and the third one is the triple covalent bond. Let us now see, using electron dot structure, to understand how these different number of bonds exist between the combining atoms. So we have single covalent bond now. We are going to see how only single bond is formed between the 2 combining atoms. I gave you few examples. Let us see the examples. Very common example is hydrogen chloride, HCl. As you know, for an electron dot structure, we require only the valence electrons around the combining atoms. So hydrogen has only one valence electron. We can write 1. For chlorine, as you know, there are 7 valence electrons. So we can put these 7 electrons around the chlorine atoms. Now next stage will be to make each of these atoms stable. Hydrogen can become stable by completing its duplet, that is by having 2 electrons. So for having 2 electrons, this 1 electron will be taken from chlorine, because this hydrogen already has 1 electron, 1 will be taken from chlorine. Now you can see hydrogen has 2 electrons with it, which has made hydrogen stable. Similarly, hydrogen has 7 and it can become stable after completing its octet, that is with 7 electrons in the last orbit. So 7 it already has, it needs 1 more electron which will be taken from this hydrogen. So 7 plus 1, it also makes 8 electrons for chlorine atom. This is how the stability is attained. Hydrogen has attained the stability by taking 1 electron. Similarly, chlorine has become stable by taking 1 electron from hydrogen. So both are sharing their electrons to become stable. And these 2 electrons which have taken part in the sharing process are called shared pair of electrons. Now one shared pair of electron will give 1 bond. So this can be formed, or this can be shown in the form of bond. We have this bond between hydrogen and chlorine, which has been developed due to the sharing of these 2 electrons. Let us see one more for hydrogen H2. There are 2 hydrogen atoms. As you know, each hydrogen atom has 1 electrons in the last orbit, which is the valence electron. So we require 2 hydrogen atoms. Now these hydrogen atoms require 1 more electron to become stable, which will be taken from the other hydrogen atom. And even this hydrogen atom also requires 1 electron, which will be taken from the other hydrogen atom. Again, each hydrogen atom has shared their electrons to become stable, so there will be a bond which will be formed between these 2. And this is the single covalent bond form. So we'll see once again one more example of water, H2O. Oxygen has 6 valence electrons. We are going to put 6 electrons around oxygen atom this way. And you can see there are 2 hydrogen atoms. Each hydrogen atom has 1 valence electron. We are going to write 1 electron for each hydrogen atom. Now let us do the sharing process. Hydrogen needs 1 electron to become stable. It will take from this oxygen atom. Same way this hydrogen also needs 1 which will be taken from the same hydrogen oxygen atom and has become stable. Now oxygen, you can see it has 6 valence electrons, so it requires 2 electrons. Since 2 electrons of oxygen atom has been given to each of these hydrogen atoms, so it will also take electrons from the hydrogen atoms. So 6 it already has, 7 and 8. Now the total number of electrons for oxygen atom has become 8 and it has become stable. So this way single covalent bond is formed. You should also try these 3 examples for the formation of single covalent bond, and tomorrow I will show you the formation of double covalent bond. Till then, thank you.